everybody. Thank you very much for the Centre Francilien of Innovation to give me this opportunity to present Watchfrog. So Watchfrog is a biotech company, and we create small tadpoles that light up in response to contaminants in water or chemicals that can affect our health. So we bring this biological information in vivo, which is the true, reliable in vivo information to predict the impact of chemicals, of cosmetics, of pesticides, of pharmaceutical waste on health. But we bring it at an in vitro scale on an alternative model, embryonic stage of vertebrate, which is encouraged and considered as an alternative to animal experimentation by European Commission. So thanks to the small size of the larvae that you can see here on the 5 cents euro coin, we can automatize the readout of the biological information and the biomarkers. And you can see here a small tadpoles that light up in response to the chemicals, the endocrine disruptors that we can detect, or the genotoxic compounds that we can detect. So for example, this larvae is lighting up in response to bisphenol A, as you know, that is considered as an endocrine disruptor that can affect thyroid regulation. I would just add also one more word here on this starting point, that Watchfrog is part of the Durapol SME Association, which is the main association of SME dedicated to eco-technologies in Paris region. And I think more than half of the SMEs that are here today are part of Durapol. So we design our models to fit with the criteria defined by OECD to test to provide environmental risk assessment. So we integrate these biomarkers, genetic biomarkers that are activated by chemicals, by the different types of effects that we want to reveal, endocrine effects, thyroid, including thyroid disruptors, estrogenic disruptors, androgenic disruptors, or other types of subchronic effects like genotoxicity. And we integrate them, we link these biomarkers with reporter gene assays, such as fluorescent expression of fluorescent proteins, and we integrate these genetic biomarkers into fish eggs or amphibian eggs, and thanks to the translucency of the larvae and to its small size, we can see where the chemicals are acting on the different organs of the larvae. Here you can see the brain lighting up in red, spinal cord, olfactory nerves, optic nerves, and you can see also the muscles of the tail of the tadpole and also the muscles of the mouth. And we can quantify the amount of light to reveal the importance of the disrupting effects of the chemicals we are testing. So thanks to this quantification, we can adapt this technology to provide 100% specificity of testing of the chemicals. So this is a rapid system that we can provide in a vertebrate model, and we can provide this in to test hundreds, thousands of samples very rapidly into micro-whale plates using robotized imagery or a simple fluorescent plate reader. And I will also put in the perspective that we are developing this technology within flow-through device. We call this a frog box, and this frog box has been bought by US Environmental Protection Agency to test the quality of water, because we can put this frog box directly on industrial sites, on water treatment plant, to test samples of water that are sampled directly from the plant, from the river, and we put directly in contact in a confined frog box. We put directly in contact the larvae with the sample of water we want to test, and when there is a contaminant in water, when the mixture is containing endocrine disruptors or multiple effects, the tadpoles will light up, and this emission of light will be quantified, so we can perform a continuous monitoring of the quality of water directly on site. So, in the perspective of academic and scientific collaboration, I will just say that Watchfrog is spending more than 500,000 euros per year in research. And in the main scientific topics that we address, I have just listed a few ones here, that we are interested in identifying new targets. And when I say new targets, it's precisely targets linked with physiological criteria that can be then interpreted in a regulatory manner. And that is very important. And on this topic, I will make a specific focus on the effects of nanoparticles, and I think that's a under progress topic. We also are looking forward to develop more sophisticated tools for robotized imagery of small aquatic model organisms, to develop new gene transfer techniques in fish model. I'm not speaking about the amphibian models, because the amphibian models is just the most wonderful model to provide transgenic models, but it's more difficult in the fish, and we're looking to develop such tools. And also we are looking forward to develop new automatization tool to sort or to inject amphibian and fish eggs. So these are a few technical goals that we have in the perspective. Thank you very much for your attention.
Thank you, Mr. Lemkine.
And just one word, unfortunately I don't have the time to stay with you today, so please feel free to contact me on my email or directly on my mobile phone if you have some thoughts about potential collaboration. Thank you.